Let's take a look at this application problem dealing with scientific notation. It says Pizza Palace serves 6.2 times 10 to the fifth customers every day worldwide. Then the question is how many customers do they serve in an entire year if they're open 360 days a year? So obviously what we're going to want to do is take the amount of customers they serve every day and multiply that times 360. But these are giant numbers we're dealing with, so I think it would be best to multiply these guys in scientific notation. So we'll have 6.2 times 10 to the fifth, and we're going to multiply this quantity times 360. But how would we write 360 in scientific notation? Well, in order to be a number with just a ones digit, you'd have to say 3.6. So it's not 360 or 36.0, but 3.60. So we just have this ones digit here with possibly a decimal part of the number, times 10 to the what? Well, we would have to move this decimal place right 2 places to make it equal 360. So we'll put times 10 to the second power. So this is the same as 360. But this is a little bit better for us because they're both written in scientific notation. So let's see if we can multiply these two guys here. We have 6.2 times 10 to the fifth times 3.6 times 10 to the second. And since they're all multiplication, it doesn't really matter what order we do these. For instance, if we looked at the times 10 to the blank, 10 to the fifth times 10 to the second would make 10 to the seventh power because we can add the exponents. Now, we're not really sure about the 6.2 times 3.6, so I think I'll go to my calculator and take 6.2 times 3.6, and that would give us 22.32. So 22.32. Now a lot of students would leave this as their answer, 22.32 times 10 to the seventh. That sounds about right, but in fact there's something a little off about this. This would actually be an incorrect answer. What's missing here? Why is this not exactly in what we call scientific notation? Well, you see the 22.32 is a double digit number. It has a 22 in front of the decimal, and I actually only want a ones digit in front of the decimal. So we would have to adjust this to 2.232. You see I have to move this decimal, but now how would that affect the times 10 to the blank? Well, the 7 is either going to change to an 8 or a 6. Let's think about it. In order to make these the same number, equal the same number, this decimal place would move to the right 7 places. And since this is a smaller number, it would actually have to move to the right 8 places, 1 to catch up, and then obviously an additional 7 in order to equal each other. So this would be 2.232 times 10 to the 8th. And so this would be your final answer. This would be that many customers worldwide per year. All right, so that's how we would do it by hand. Now, very quickly, I'm going to show you how to do the whole thing just on the calculator. So if you get your calculator back out, you see this EE button above the comma. That can actually handle everything all at once. You can take 6.2 EE, this comma, secondary comma button with the EE, 6.2 times 10 to the fifth. And so that's how you say 6.2 times 10 to the fifth on a calculator, multiplied by 3.6 EE, which means times 10 to the second. Now when you push enter, it's going to multiply these two numbers in scientific notation and take care of the decimal and take care of the exponent for the 10. And sure enough, we see we get, actually it's a really big number that they didn't write in scientific notation, but it's 2232 with 1, 2, 3, 4, 5 zeros. So let me come back over here for a minute. 2232 with 1, 2, 3, 4, 5 zeros. Okay, so now if we wanted to write this guy in scientific notation, it would be obviously 2.232 that we would move the decimal place to the right 1, 2, 3, 4, 5, 6, 7, 8. Exactly what we got. So anyways, now we're confident that we got the right answer.